In this problem, our goal is to find the position of the electron with respect to its position in another axis. So basically, we're trying to find the y position of an electron with respect to its x position. In order to do this, we need to know two things. We need to know the y position with respect to time and the x position with respect to time. We should note that since we're not given any actual value except V naught, which we can just simply say is V naught, we can actually put everything in terms of the variable such as E for the E field or M sub E for the mass of the electron. So what we're going to do is we're going to first see if we can find one of these two. I think we could find x of t given that the velocity of the electron in the x direction is given, and that's just going to be 1.0 times 10 to the 7th meters per second. Well, you can go ahead and use a kinematic equation or just the definition of kinematic quantities to find that with a velocity that's constant in the x direction, you can find the position. The position of the electron with respect to time is just going to be the velocity of the electron in the x direction times time. So this is the equation. Now, being consistent with the notation of the problem, we can just say that's going to be V naught times T. Okay, so there's no need to make it too fancy and put in your own subscripts if you don't need to. Now what we need to do is find y sub t. Well, what we do know here is that the velocity of the electron in the y direction starts off, well, especially in the beginning, starts off at 0, and it undergoes an acceleration. The acceleration of the electron in the y direction ends up being a force of electrostatic force from the plates divided by the mass of the electron. Now, you know that it's going to go negative because it's attracted to the bottom plate, which is positive. So you're going to go ahead and make it a negative by putting the absolute value sign around the quantity and put a negative right before it. They're only giving you the electric field though, so we're going to go ahead and turn force into as a form of electric field. We're going to go ahead and say this then. And that's going to give us the acceleration of the electron as a function of 3 known quantities. We know the charge of the electron, of course. We know the electric field is just given in the problem as E. And we know the mass of the electron just by a Google search. So we know the acceleration due to 3 known quantities. And we can find the position from acceleration. We could do it in 2 ways. One, we could take 2 integrals of the acceleration function, one right after the other, or we can just use a kinematic equation. If you want to know the position of something with respect to time, given only the initial velocity and acceleration and time, you basically say it's 1/2 a t squared. That's the kinematic equation. So that ends up being 1/2. In this case, A is negative Q of E over M of E times time squared. And that ends up being negative 1/2 Q of E times E time squared over ME right there, okay? And all I did was I just put in the 1/2 into the equation, which is not much. I can simplify this even further by making it so that this 2 goes on the bottom. And I guess that's all you can really do, and just get rid of the 1 here on top. So you got 2 ME on the bottom. Now this is not enough because what they want at the end game here is to get y in terms of x. So this is where we look at these 2 parameters here, and we combine them with the common function of t. So you have x of t and y of t. What we're going to do is we're going to get t in terms of x, and we're going to plug in that t right here. So let's go ahead and do that last piece in this box here. T is equal to x of t divided by v naught. So now if we want to plug it into here, we're going to get y. Now it's going to be of x because we have replaced t with a function of x. So it would be y of x. And if you want to be specific, it's actually, it could be y of x of t. And that's going to equal to negative QE, I'm just copying from here, t squared, so it's just going to be x of t squared divided by 2me v naught squared. And that's basically plugging in this value to t and then squaring it. So the final value is right here.